So I was hoping that you would go through and work through this example prior to looking through this, the work for this. So if you haven't done so, pause the video, make sure you do that before you go through and see how this works. So example 2, in August and September 2005, Hurricanes Katrina and Rita caused extraordinary flooding in New Orleans, Louisiana. A prevailing thought that those that volunteered to extensively clean flood-damaged homes would subject to hazardous conditions due to large amounts of mold in many homes. In a random sample of 365 residents that participated in cleaning one or more of the flood-damaged homes in New Orleans, reported that 77 experienced severe wheezing. In a random sample of 179 New Orleans residents that did not participate in cleaning a flood-damaged home, 23 experienced severe wheezing. Is there evidence to suggest that the proportion of people that participated in cleaning one or more flood-damaged homes in New Orleans and experienced wheezing is different than the proportion of people that did not participate in the cleaning the flood-damaged homes in New Orleans and experienced wheezing? Test at the 1% significance level. All right, so this is finally a problem where we're going to have a two-tailed test, and I'll explain why in a moment. Null hypothesis, we're going to assume that the proportion of people that clean the homes and experience severe wheezing is the same as people that did not clean the flood-damaged homes and experience severe wheezing. The alternative, P1 is not equal to P2, and here's why. We look at the question and we see that is the proportion different than? So it doesn't say greater, it doesn't say less, it just says different than. Right? Of course, we need to make sure that we define the two groups, just like we did in the previous. The two groups are the people that cleaned a home and the people that did not clean a home. Okay, so the first group that we're looking at, the ones that cleaned one or more flood-damaged homes. So let's say this is the group that cleaned, and P2 is the group that did not clean. So the next thing we're going to do is we're going to gather up some variables. Okay, so the group 1 is the group that cleaned. Group 2 is the group that did not clean. So P sub 1, if we go back up to the top, there were 365 residents, and of the 365, 77 experienced severe wheezing. So it would be 77 out of 365. All right, and I'm going to type that into the calculator. I'm going to round it to 3 decimal places. So that's going to be 0.211. Q1 is going to be the complement, 1 minus 0.211. That should be 0.789. I'm going to test that just to make sure. Check it in my calculator. And then the sample size, 365. We're going to go back up to the top. We're going to look at group 2, the people that did not participate in cleaning the flood-damaged homes. There were 179 folks, and of those 179, 23 experienced severe wheezing. So for P sub 2, that's going to be 23 out of 179. And again, I'm going to type that in my calculator. I get 0.218. All right, so, or 128, excuse me. Let me erase that. So that is 0.2128. Right. Q2 is the complement. That's 1 minus 0.128. And that should be, if we subtract correctly, that's going to be 872. And I'll check that in my calculator. 872. And then finally, N sub 2 is going to be 179. Last piece of information we need from the problem is we need to determine what's going to be the significance level. In this case, we're going to test at the 1% significance level, so alpha is going to be 0.01. We're going to draw the distribution now. It's a two-tailed test. So here's our distribution. The range of values, 0 to 1. We have a left tail, and then we have a right tail. Now remember, for the left tail, for a two-tailed test, we have to split the alpha in half. So alpha over 2 in this case is going to be 0.01 divided by 2, or in this case, the left bound is going to be 0.005. And again, you can stick that into your calculator just to verify it. For the right bound, 1 minus alpha over 2, or in other words, 1 minus 0.01 over 2, and that's going to be equal to 0.995. Anything less than 0.005 or greater than 0.995 is going to be a reject. Anything between those values is going to be a fail to reject. Now we're going to compute the standard deviation. Remember our formula. Now just write the formula out. So P1, Q1, N1, P2, Q2, N2. We're going to go ahead and compute. So that's going to be the square root. And we said P1 was 0.211. We're going to multiply that by 0.789. We're going to divide that by 365. P2 we said was 0.128. Q1 is going to be 0.872. And then we're going to divide all of that by N2, and N2 was 179. I'm going to throw that into the calculator. We're going to approximate it to 3 decimal places. If you have trouble putting it in the calculator, take a look back at the previous video that has detailed instructions on the syntax. I got 0.033 for my standard deviation. Finally, we're going to compute the z-score. Remember our formula, z equals p sub 1 minus p sub 2 divided by sigma p1 minus p2. We found that p1 was 0.211. We found that q1 was 0.128. We're going to divide all of that by 0.033. And I get 2.52, excuse me. Last thing that we're going to do is we're going to go into the z-table and we're going to convert that to a p-value. So we go into our z-table and we're going to go into the positive side. We're going to look up 2.5 and then we're going to go over to 2. And I get 0.9941. And that's our p-value. Now we have to be extremely careful with this one. So we're going to go back up and we're going to plot 0.9941. Alright, and this very rarely happens. But it just so happens that 0.994 is just a little bit less than 0.995. So this is our p-value of 0.9941. Alright, so we are literally about 9/10,000ths away from having a reject. Alright. Our conclusion, let's type this out. Since the p-value falls in the fail to reject region, we fail to reject the null hypothesis. Hence, we're going to say that there is not evidence. And I'm going to go all the way back up. I'm going to copy the question. So we're going to say, hence, there is not evidence to suggest that the proportion of people that participate in cleaning one or more flood-damaged homes and experience weeding in New Orleans is not significantly different than the people that did not clean the homes. All right. So make sure that you're okay with these concepts. And at this point, I would suggest that you go through and work some of the assignment problems that are related to the hypothesis test of two proportions.